If it's false, then it will not be included in the parent RDD. So the example there is pretty simple. Well, it's looking filter by odd number. So only odd number will appear in the parent RDD. Okay? Sorry, in the child RDD, not the parent. X is the parent, Y is the child RDD. Okay, so yeah, filter is pretty simple. Flat map. Have you guys worked with flat map before?
No.
So flat map is just like map. This is creating a lot of confusion for people that started working with Spark or Scala for that matter. With map, what you do is you take one object, you return another object, right? That's what map does. Flat map is what you do is sometimes you take an object and you want to create multiple objects out of it. For example, you take a line, right? And you want to split that into words. So therefore, what you want to return is a list of words, right? If you just do a map on that, it will return you a list of words. But what you want is just words, not list of words. So flat map takes your list and flatten it out in the final result.
Got it. That would have been helpful at other points.
Yeah, so in this example, they iterate to the array 1, 2, 3. For each of the values, it returns an array, right, from n to 100.
Yeah.
Yeah, so therefore, when you flatten that out and become individual values. So that's the difference between flat map and map. But once you understand it, it's pretty straightforward. Group by is exactly how it works in SQL world. You group by key. So in this example, they group by the first letter of the name, effectively. So X contains John, Fred, Anna, and James. And what do? They group by the first character, effectively. So all the names with the A's go together, all the names with J go together. So that's what you get in the output.
So when would you use like group by versus reduce by key? Because all of those things are essentially ways of grouping by a common characteristic.
So in order to do reduce by key, you would have to do two things if you're going to do group by first. The group by will give you the key and a list of values for that same key. It doesn't give you a count yet.
It doesn't reduce anything.
It doesn't reduce anything. So the output is you got J, you got Johns and James. In order to find how many J's there are, you have to do reduce by key. So
yeah, so essentially it creates a dictionary, right? So it's just
yes. Like... So basically, perform a grouping by the key. That's all. And then you have the group, and you can do any kind of processing on this group, right? The group reduced by key is one specialized group operation, and then do the addition of the, not addition, but any kind of reducing on the values for each of the keys.
So is Y the paired RDD now?
Group by doesn't work by the pair RDD.
Also, Y is not a paired RDD.
Yeah, as you can see on the group by, you're telling it the first character to group by, but there's no key value at this point. In order to
but it creates a pair RDD, right? Because it creates a set of tuples.
It could create a set of tuples, but not a pair RDD.
Yes, if you go to that one. Is Y a RDD?
Was a set of tuples.
Yeah, I thought so too.
When you try this out, you see it. Whether that creates. Let me try this out. Where's my Spark shell? My Spark shell is gone now. Okay.
But why? I mean, just in theory, can you explain why what would we need? Put it this way: what would we need to do to transform Y into a pair RDD?
I'm sorry, say that one more time.
What would we need to do to transform Y into a pair RDD?
Oh, so the moment that you do flat map or map whatnot, you put in a tuple. You create a tuple out of it in the output.
And what do we do?
Oh, it's because it's in an array. I see. So it's if we just flattened Y, then we would have a set of tuples that would be a pair RDD. Is that right?
Hang on, let me try this real quick and then I'll answer you. So parallelize and then Y. So create that, and then I do a group by, and let's see what it returns.
You drag the terminal over to your screen.
Oh, you see it?
No, I think it's when you share screen, you choose the whole screen, not only the PDF. Then we'll be able to see the shell.
Oh, I see. Entire screen. Okay, how about now?
Yeah, just whatever you do. Yeah, got it.
So you see that, let me resize this a little bit. So right here, I parallelize the array, I create a parallel collection RDD, and then I do group by. It all does is create me a shuffle RDD with a char and iterable. It's not a pair RDD. So that's the slight difference.
Thanks for the help.
All right, so group by key, it works on the pair RDD. Here's an example. The example, as you see, is all tuples, right? An array of tuples. So that's why I see parentheses. So when you group by key, it does.
Back to there. Thank you.
The group by key doesn't take anything except number of partitions. So because the input's already a pair RDD, right? So it knows which one is key, which one's value already.
Yeah.
That make
So
sense?
here X is a pair RDD.
Yeah.
What's the difference between X here and Y in the previous slide?
Let me try that, and then we'll see. So I do that. It's parallel collection RDD is a tuple. That.
So the only difference I see between is X and Y is that Y had the second element be an iterable string instead of an integer.
Say that
if you
one
look
more
at
time.
the beginning. So if you read the beginning from your terminal, if you look at the line with Y, right? It says Y is an RDD that is an array of tuples where the second element is iterable string. Whereas X is an array of tuples where the second element is an integer.
Yes.
So is the fact that so I guess the first question is, what is iterable string?
Iterable,
and then
just, it's a when you're working with collections, you want to have a way of iterate through each of individual elements. So it creates an iterable interface or a type, if you will.
And is that what makes it such that it's a shuffle RDD instead of a pair RDD?
So the question is shuffle RDD a pair RDD? I think that's what your question is. And we'll find out. The shuffle RDD extends RDD.
It's okay. This is less important, so maybe we should just move on.
Okay. All right. So group by key, we good, right?
Mm-hmm.
Yeah.
map partition. So map partition is the optimized version of the map transformation. The way it works is the map partition runs your mapping logic at the partition level, and here is what I'm talking about. Oh, what happened? That's all I was saying. Oh, okay. So, oftentimes you use map partition because you usually create some kind of object or any kind of parsers, and then you use that parser to parse individual lines. If you just do straight map, then you create a parser for each line. Map partition allows you to do is create that object once, and then iterate to each of the records in a particular partition. So therefore, you only have to create that parser object once instead of one per line. So that's the difference. So this is, so they go through the difference between reduce by key and group by key. So we create an array, we do parallelize, and then we create a tuple out of that. And then in this case, reduce by key. And the second example is group by key and then do the sum, right? So group by key would just give you a key and a list of values. In this case, when it does the map after the group by key, it spits out a tuple with a key, and then the sum of all the values of that key. Right, this is what I'm highlighting. You guys see that? So
yeah.
That is the same as doing reduce by key, but it's less efficient. And hopefully,
so the output of those two things is the same.
Yes.
I mean, the output of like the first set and the second set.
Yeah. But the difference is the second one is not efficient. The first one is a lot more efficient. And this is the example that they go through here, which can illustrate it for you. So reduce by key, reduce all the values with the same key in the same partition first. Okay? Like the second block, all the A's will come together and reduce by key, the values will be reduced in that partition. So that's why I see 2. And then finally, it does the reduce by key across partitions. And that's when you see A6 and B5. Right? And then the difference between group by key is first, it shuffle all the pairs, all the A's will come together first. And then the B, and then finally does the reduce.
Yeah.
So you see the difference, right?
Yeah. So reduce by key is more efficient.
That's why group by key is less efficient, because it's unnecessarily, shuffle things around. It doesn't do local reducing first. So here they mess up the slide. So map partition. So we're back to map partition. It's run the map partition. We try to apply a function to each partition on this RED. That's the only difference between map partition and map.
Okay. So, sorry, Hyun, will the map partition, do we get the same result, but it's just that map partition first operates on the partition and then brings everything together, kind of similar to what you just showed with the reduce by key and group by, where it operates on the partition first and then brings everything together instead of shuffling first?
Right, exactly.
Okay. So if we know that something would be more efficient if you operated on the partition first, then we should call map partition.
Yeah, in particular, like the example that I gave, if your data is a bunch of lines, right? And you need to parse it. And with map partition, you create the parser only once per partition, and you reuse it for each of the record in that partition. Right? Yeah.
I see. Okay.
All right. So map partition with index, so it's just similar to that, but it's just working a little bit different. That's all. All right. Sample. this is a transformation for do sampling, so it's pretty straightforward. It shouldn't take long to go through this. The one interesting first parameter is with replacement or not. So it's a true or false value. Do you guys understand the difference between with replacement or without replacement? Does that make sense? Okay, so we can just skip through this. Union is pretty straightforward. You take two RDDs, you union them together. The only thing you might want to pay attention is there might be duplicates.
So union is sort of like appending records to an existing data set.
Yeah. Mm-hmm.
It's not a join. It's not. If I think about it in a,
it's not a join.
Like, relational database framework, it's not adding columns. It's adding rows.
Yes, that's correct.
I have a question on this. What's the array 1, 2, 3, comma 2 mean here for the x? What is the comma 2 for x mean in the parallelize?
When it says sc.parallelize array 1, 2, 3, comma 2,
yeah,
the last parameter is for the number of partitions.
Oh, you're right.
Yep.
And what's glom?
Glom?
Yeah.
I don't use it that much, but it does. Hang on. I try it out in glom. Return an RDD created by coalescing all elements with each partition into a list. It's almost like into a list and then you collect. Ah, I see. Okay.
And why does Z have like tuples, like 1, comma 2, 3, comma 3, 4? The class is like.
Oh, I see. So tell me if I'm wrong. I'm gonna try to. So when you write x, so x sc.parallelize 1, 2, 3 on two partitions, it ends up writing 1 on one partition and the array 2, 3 on another partition.
That's correct.
And then because you called glom, it's separately bringing in what it finds on different partitions, but without flattening them. So that's why you end up with 1 and then separately 2, 3 and then separately 3, 4.
That's right. It creates a list out of that.
So if when we wrote x, if we had parallelized x on just one partition, then we would have had then Z would have been 1, 2, 3 and 3, 4.
Yeah, exactly. Does that make sense, Natalie?
Yeah. That makes sense. I feel like the
coalescing all the elements within each partition into a list and then return that.
Yeah. Okay. It's a random partition, right? If I say 2, like why 1 coming 2 and 2, 3 together, it could be 1, 2 together and 3, right?
Yes. Yeah.
Cool.
All right. Join, you guys don't need join. Join works on a pair RDD, of course. You have to have key and value.
Yeah, we might need join actually, so.
Yeah, and anytime you have two data sets with the same, like member from two data sets, member key, then you have to do join. So what does it give you join? So join gives you the join key and then all the values of the same keys from both data set together. So you can see that.
Yeah. Okay. This seems pretty straightforward.
Distinct. It's exactly what distinct says. Removing duplicates. That's all there is. So distinct and join, of course, requires shuffling data across. It's a wide dependency, like what we talked about, right? In order to do distinct, you have to collect all the same values together first. So that requires shuffling.
But couldn't you do, I mean, for distinct in particular, you could first do it on the partition and then bring sort of distinct partition.
Yeah, I mean the optimization would be similar to you reduce by key, right? You do per partition
but that's already,
first.
Yeah, sorry.
And then across the partition, yeah.
And that's already, but Spark already, the way that distinct is written already does that, right? I assume.
It should, yeah.
Yeah.
Definitely it should. All right, coalesce. I think in Oracle has this keyword. Coalesce is a way of let's say you have an RDD that has 10 partitions. And, well, okay, let me back up. Let's say you have a data set that's large, right? And then that might be 100 partition. And then you do filter. And it can go from 100,000 record to maybe 50,000 record. Mm-hmm. Therefore, each of those 100 partitions will have much less data than before, right? So, and then if you do any kind of transformation, then they have to fire off that many tasks, one per partition. So therefore, it'll be more efficient to reduce the number of partition down to smaller value for efficiency purpose. So you're basically reducing the number of partition in your data set. And that's what coalesce is for. So for example, it's saying that create 3 partitions out of that 5 elements array, and then coalesce that down to 2 partitions. That's all that is.
And do you always have to specify how many partitions to coalesce it to?
Yeah. It takes a value.
What if you don't know, what if I don't know how many, when I call my filter, I don't know how many records it's going to result in?
Good question. So if you look at my console, you say x dot. What happened to the code completion?
Or also, I don't have a sense of how many records I'm supposed to put on a given partition. If
you look at my console, any RDD, you can say dot partitions, dot length. It will tell you how many partitions in that RDD.
Okay.
And then because it's, you can use this, right? If it's 100, then we divide it by 10 or whatnot. And then use that in the argument for coalesce. So you can always find out for an RDD how many partitions it's currently at.
Right, but I don't know how many partitions it should. Wait, the 2 here is how many partitions I want to reduce it to.
Yes.
So if I don't know, so say I start with an RDD that has 8 partitions, but I'm filtering to only names starting with A, but I don't know how many names starting with A I have. How do I know how many partitions to coalesce to?
You don't until you do a count and then you find out how many.
Okay, fair enough.
Usually it's an iterative process.
Uh-huh.
Yeah. Key by doing forming 1 pair for each item in the original RD. The pairs key is calculated from 1 value and supply function. So key by it's you do char at 0 and then that's all it's doing. Huh.
How is this different from group by?
This one is not doing any kind of grouping though. It's a parity form 1 pair for each item, so it's not doing any kind of grouping.
But the result looks the same, right? As the group by.
The result looks similar, but it's actually each element is a tuple. It's creating a pair RDD.
Oh, I get it.
The key
because
is
here
whatever you...
J John and J James are separate.
Exactly.
Whereas with group by they were in the same.
That's correct. Because
so why here is a paired RDD?
Because that's what key by does. The description says create a pair RDD, forming 1 pair for each item in the original RDD.
Got it.
Yeah. So instead of using, previously what we do is we map, right? When we do map and then we spit out a tuple with a key and then the value, in this case, key by is doing exactly that. Partition by. Oh, partition by is similar to RDD, but sorry, similar to coalesce, but it is more flexible. But the point of that is it's the end result is similar by partitioning your data. Okay. And
but
you can.
So Natalie, I think this is sorry. Natalie, I think this is what we might want to use. So Ken, we have so the way we're using this, right, is because we want to compute a number of statistics on a lot of different subgraphs.
Yeah.
But actually what we realized is that a lot of our subgraphs are going to be pretty small. And maybe actually the most efficient way, but we wanted still to use Spark because it has a library that has a lot of built-in, GraphX is a library that has a lot of built-in functions, so we don't have to, rewrite them.
Yeah.
But if we want to, since our subgraphs are going to be pretty small, each subgraph can fit on a single partition, we think.
Yeah.
And so what might be most efficient, we were thinking, is to actually assign each subgraph to all be on one node, and then you can essentially in parallel oh, okay, sorry. Well,
I think
let me
yeah.
Yeah, we're time's
Looks
up.
like
Okay.
we might need to schedule another one.
Yeah.
Okay.
Well, this is very helpful. Yeah. I think
This was really helpful. Thank you.
Yeah.
When do we think is a good time to schedule? I can send out the invite.
So let me get back to you in terms of my availability, and then we set one up. Okay.
Okay. Thank you so much, Hin. I will.
Thanks a lot, Hin.
Yeah.
You're welcome. Have a good lunch.
All right.
You too. Bye. Thank
Bye.
you.
Bye.